Our attention, though, has some blind spots that can be tricked. It can be misled in a few different ways. Our attention could be drawn elsewhere. We could fail to perceive certain objects in our environment, and we could fail to perceive unanticipated changes. We're going to talk about a phenomenon called change blindness that does this. But magicians operate by tricking your attention. They know which types of things tend to draw people's attention and which types of things you're not going to notice. So they do all their sneaky changes using things you're not going to notice by drawing your attention elsewhere with some distraction, right? That is what sleight of hand is. Now, I don't have any sleight of hand examples to show you, but there are some psychology research examples that demonstrate our attentional blind spots pretty well. One of these is called the attentional blink. This is when we're shifting our focus from one thing to the next while our attention is moving. So if you think of that attention kind of like a spotlight, when it's still, you are illuminating something in this dark environment and you can see whatever the light is on. And you can move this spotlight, you can choose where to move it. While you are moving it from one object to the next, while it's in motion, you're sort of blind. You're just seeing a quick blur. It's not vision, right? But the vision is just an analogy. So imagine with the spotlight, you're just seeing a quick blur while the spotlight is moving and you can't actually tell what objects are there. Similarly, while you are moving your attention from one task to the next, like between thinking about composing your text message and keeping your attention on the road, every time you switch from one task to another, your attention is actually blanked out while it's moving in the middle. You lose about half a second of attention. The length of this attentional blink stretches as you age. So by the time you're in your 60s or older, it's about a whole second. And think about this. You may have good reaction time, but if you're not paying attention to the road pretty constantly, and you're following very closely to another car, you have lost some of that time when you switch your attention from your phone back to the road, so that you don't have time to brake correctly before you actually rear end them. The same thing applied when I was in college. There were a lot of people on bicycles all over campus. Sometimes I was the bicyclist. And if I wasn't careful, if I wasn't keeping my attention on my surroundings, I could easily get bumped into by a bike, right? Or have a very close call, because I would lose a half a second of my attention each time I'm thinking about what I'm listening to in my headphones versus thinking about the space around me and the people moving around me. How do we know how long the attentional blink is? Researchers use a method called RSVP, Rapid Serial Visual Presentation. Here's an example of what RSVP might look like. You might be asked to look at a PowerPoint screen and there's a letter in the middle of it, and every 115 milliseconds, so just over a tenth of a second, the PowerPoint would switch to a different slide very quickly with a different letter on it. And imagine that your task as a research participant would be to press the spacebar on the computer every time you see an M appear on the screen, or every time an X. And here we have H and then M and then K and then X and then A presented in that order. So you have two targets you're looking for, M and X. You press the spacebar when you see either target. So you press the spacebar when you see this M. Your attention is now on M and on making that response. And it's going to take you half a second to move your attention from M and from pressing the button with the M to back to looking for X, okay? And so by the time your attention is back on the screen looking for X, X has already passed. It's only been 230 milliseconds and X has already come and gone, okay? So if your second target appears in less than that half a second, you won't notice it. You won't ever press the space bar for X, even though your eyes took it to your occipital cortex for your vision. It was in your sensory memory, but your attention was not on it because your attention was still on M and pressing the button for M. There's also a related phenomenon called repetition blindness. And this would be something like, imagine that the K in this slide is actually a lowercase m. And I said, press the button every time you see an M. And you would press the button for the capital M, but you would skip the lowercase one because your mind would actually kind of meld those together. If it's under half a second, they would just see it as one M, even though they look different. Even if it was like letters that look a lot more different, like capital R and lowercase r, your attention kind of smooshes them together and you think you only saw one R.